So the first thing we're going to do first, let's illustrate this. Let us get an illustration first. Let's get a picture of what we're about to do. Let's say the body was thrown from this place. The body was thrown from here, from this angle. Now don't forget that's the stone A. That's the first stone, stone A. This stone A. Now the stone was thrown from this place. Now don't forget that it was thrown with an initial velocity of 20 meters per second. Now don't forget that's initial velocity along the y-axis. So you're going to state them out. You're going to state out the parameters. So initial velocity is 20 meters per second. Now don't forget that this acceleration along y-axis. So it means everything we do here is fixed. Acceleration along the y-axis is often a constant, which is 10 meters per second squared. So when the body is being thrown up, it means gravity is being disobeyed. So it's going to be a negative gravity. While when the body falls, gravity is being obeyed. It's going to be a positive gravity. So initial velocity along y-axis is 20 meters per second. Then acceleration along y-axis is going to be positive gravity. I beg your pardon, negative gravity, which is minus 10 meter per second squared. Don't forget the body was thrown up. So if a body is being thrown up, it's going to be negative gravity. But if a body falls, it's going to be positive gravity. Now it was thrown with this velocity. Now don't forget that at max height, the final velocity at max height is 0 meter per second. Now it's a simple fact. When the body is being thrown up, the body can't keep flying forever. To get to a point whereby it loses all its initial speed or velocity, then it starts falling back. So at that max height, the final velocity is 0 meter per second. So there are two things I would love us to look for. The first thing you're going to look for is the time it takes the body to get to maximum height. And also, you're going to look for the total distance it covers, up to max height, up to maximum height. So the time it takes the body to get to max height, we don't know. We're going to look for that. So the total distance along y-axis, which is taken as height, so that's going to be, we're going to look for that. That is, we don't know what it is, but we're going to look for that. So first of all, let's get it to that time it's going to take the body to get to maximum height, So we have our parameters already. We have our final velocity to be 0 meter per second at maximum height, initial velocity to be 20 meters per second at maximum height, acceleration is minus 10 meters per second squared because the body is flying against gravity. So what's going to be the time? Now we're going to use the v equal to u plus eta. That's the first equation of motion. It's going to come in handy here. So v u plus at. Don't forget everything here is along y-axis except time, which is a scalar quantity. Time doesn't have a business with either it's along y-axis or x-axis.